Hi again, everyone. This video is a kind of types of reactions, special types of questions, particularly important types of reactions, these distinguishing reactions, and also reaction schemes where we have a step, and then finally we get to our final product. We have more than one reaction before we get what we want, which is often what we have to do in organic chemistry or in lots of different circumstances. We can't just go straight from our starting product to our final product. Sometimes we have to take a step in the middle, like we saw with Hess's law, and we took advantage of that in our calculations. So first of all, these distinguishing questions. Now, when we saw the summary last time, and you've done many summaries, I've been pointing out, been trying to anyway, these special reactions. And been saying they're particularly important because we can see something, we can see the change, and so we can use those for distinguishing that compound from something else, because we can see a change with an alcohol and Lucas reagent, but with other substances, we can't. And actually, for Lucas reagents, different between primary, secondary, and tertiary alcohols. So we can even see that. Oxidation reactions are particularly useful for distinguishing because we can see the color change if we use permanganate or dichromate or Tollens or Benedict's. And then another way of distinguishing things is a kind of chemical reaction, but it is the chemical change in the indicator litmus. And so that's really good for acids and bases. Only acids will change litmus red, only bases will change litmus blue. So if we look at some of these examples, then you need to think about what kind of compounds are these, and does one of them, often it is just one, sometimes both, but does at least one of them have a reaction that we can see the color change for? So here we have an alkene and an alkane. And if we have a look here, alkanes actually don't have reactions that we can see, but alkenes with addition reaction will react with orange bromine, and after the reaction, the orange color disappears. So we've got a reaction there. So the reagent here, we would use bromine as the reagent, and then you need to describe what would we see with which one. Sometimes it's useful to put a label on these, but you can name them, or you can say the alkene, or you can put a number label on them if you find that a little bit easier to write it quickly. So something like that. Orange propene will change, or sorry, colorless propene will change orange bromine to colorless. Colorless propane will not change with orange bromine. So I've said the color before and any change, or if there's not a change. All organic molecules are colorless, so that might get away with not saying that. It might be understood, but it's easy to add that on. All right, so when I see you, I will be asking as many of you as I can to try some of these yourselves. So be good practice revising what are the structures. This one is an aldehyde, this one is a ketone, and so hopefully you know aldehydes can be oxidized with many oxidizing agents, and ketones cannot. This is a primary alcohol, this is a secondary alcohol. So that's part of these questions, is identifying what type of molecules they are, but then also knowing what can we use where we can see a difference between them. So this is one of my favorite types of problems because it's kind of like a problem solving, like a little puzzle. But it's also very necessary for a lot of organic reactions. If we start with an alkene and we want in the end a ketone, we can't do that in one step. We have to do that in more than one step. And so being able to solve these kind of problems is a very useful skill. You need to think, okay, what can I get in the middle to get there quite efficiently, and what reagents would be needed. One of the tricks for solving these is you don't need to start at the start. You can start in the middle, or sometimes it's easier to start at the end. You can start anywhere you like. So for this one, I'd look at it, okay, alkene. You might think, oh yeah, I know this addition reaction, and so I can put my product here, but you might also think, oh wait, there are two possible products there. And in fact, this is part B question is what is the other product from step one? So how do I know which one is here? Well, I need to look at the final product in order to know what's going to be here. This is a ketone, pentane 2-one. So I'll draw that out. And so the oxygen group is on the second carbon. So here, the oxygen group has to also be on the second carbon. So it must have been pentane 2-all. And so that is the major product. It didn't say that here, but it is the major product. And then to change from that to the ketone, it needs to be oxidized. That's oxidation reaction. And alcohols need strong oxidizing agent, but you have your choice. Dichromate in acid or permanganate in acid. Does need to be done in acid conditions, and you can write the formula like that, or you can write the name. So the other possible product is pentane 1-all, where the OH is on the carbon with 2 hydrogens and the H goes to the carbon that had only 1 hydrogen. That's the minor product, but it is possible, and there would be some of that. And so that's a beginning example. There are a lot more examples here. Here's a really long one. And again, for this one in particular, don't need to start at the beginning. Ask yourself, which part do I know? Look at the whole thing and start with whichever part is the easiest part for you. We'll look at some of these together. And when I see you, have a good one. Bye-bye.